Thanks for having me today. I'm going to spend a little bit of time talking through MEMS, particularly as sensors, and I'm going to focus more on the sensor aspect of MEMS. Before I do that, though, I thought I'd take a few minutes and kind of give just an overview of where Freescale sees the semiconductor market in general going. We've had a rough 2 or 3 years, but the outlook actually is very exciting for the semiconductor industry. I've been in this industry since 1984, and I actually look out into the next few years and see this as potentially the most exciting and potentially the most lucrative time for the semiconductor industry in general. And I'll tell you some of the major reasons why I make that statement. You know, I got into this industry and I got to witness the exciting growth of the personal computer industry. And the personal computer industry, by all accounts, has been the industry that fostered the most innovation in semiconductors and created the most wealth in semiconductors. Certainly, the number one semiconductor company in the world got there because of the PC industry. But now, we're in a post-PC world, and we see computing moving toward mobile computing. And the reason this is so exciting is because there's been an invention that happened in your and my lifetime, which we would be hard to argue is not perhaps the most exciting invention of our lifetime, and that is the internet. You might say it's not number one, but certainly be number 2 or number 3, the most incredible invention we've seen. We use it every day. But the truth is, today, only about 25% of the world's inhabitants use the internet. So we got about 1.7, 1.8 billion people using the internet. We see that number doubling in the next 5 years to where half the planet is online. And that planet is going to come online with mobile computing devices, with mobile phones, with tablets. We call them smart mobile devices, inexpensive devices that are battery powered and able to come on the internet. We see great innovation and wealth opportunity in this market. You know, the PC industry got where it was today by serving only about 10% of the planet's inhabitants. There was only about 10% of us who had the wealth or means to afford a personal computer. But now we see the smart mobile devices being able to serve half the planet's inhabitants. So it creates a dramatically higher volume for semiconductors. And I'm going to focus on some of the ways that sensors are active in that as well. The second major market that we see a huge potential for is in the energy market. You know, one of the biggest problems we have on the planet right now is only about 2/3 of us are on the grid. Only about 2/3 of the planet's inhabitants have electric power. And we see that becoming more pervasive over the next 5 years. However, that means we either have to build more nuclear power plants, and at this point nobody wants that right now, or we build more coal power plants, and we all know the negative CO2 effects that fossil burning power plants have. But there's a growing trend toward what we call smart energy, which is 2 pieces. It's the smart grid. It's bringing intelligence to the power distribution grid up to the meter. But then even more important, it's the smart energy management inside the home. You know, the energy management inside the home is very interesting, but today, none of us knows how much energy each of our appliances are using. We buy electricity for a month. We don't know what our bill is going to be until after we've already bought it, and then we get the bill and we have to pay it. But we're making devices that allow the users to be able to have, through intelligent communication with their appliances, back to a home energy gateway, great insight into how much electricity is my refrigerator or my air conditioner or my appliance using. So a lot of innovation happening in the smart energy area. And third has to do with the medical area. I'm going to leave that one and discuss that during my talk. But in general, we see excellent opportunity for dramatic growth and dramatic innovation in the semiconductor market. So I know we've been talking about this. Today's a MEMS day, and MEMS have a wide variety of uses, but today I'm going to focus primarily on the sensing aspect of MEMS. Sensing might be the top 1 or 2 functions of a MEMS device today, and MEMS is definitely an ideal technology for most of the sensing applications that it's used for. It is low cost, it's very small in size, it's efficient in terms of power consumption. So Freescale focuses on MEMS for sensors, and that's what I'm going to cover today. I'm going to talk about 2 trends. The first trend has to do with multiple sensors in devices. So we see the growth of sensors as a very dramatic growth. Over the next 2 years, we expect a 5-fold increase in the number of sensors that are being used in mobile devices. So this means that we have devices like accelerometers, being used in most all mobile devices today. The next generation of mobile devices, almost all of them will have magnetometers, because you may know that a compass function is required to get certification for Google's Android operating system. So certainly location-based navigation, very important with sensors. After that, we see gyroscopes being added in for gesture recognition. So multiple sensors. Today, I think Alyssa, you already mentioned 3 devices per phone, 3 MEMS devices. We know that last year, about a third of all phones had accelerometers in there. This year, it's going to be more than half of all phones have accelerometers, and then gyroscope and magnetometers being added on. So we see a huge increase in the number of devices that are going to be used in the next 2 years. I'm going to use Freescale as an example of the industry in how MEMS devices have been developed. It's not a new technology. In fact, the first time that Freescale got involved in MEMS was in 1980. And certainly the industry that was innovating in terms of developing MEMS technology is the automobile industry. The first place we saw automobile technology being developed was for tire pressure sensors and for inertial sensors in airbags. So in 1980, Freescale developed our first pressure sensor and brought that to market with some of the very high-end cars like the Mercedes S-Class automobiles back in the 1980s using tire pressure sensors. The same category of cars then in the late 80s began to develop pressure sensors and inertial sensors for the deployment of airbags. So automobile was the primary mover for the first decade of MEMS devices. The second decade had a lot to do with medical. And in fact, in the professional market, many of the blood pressure sensors that are developed today use MEMS sensors to determine our blood pressure. So when you go to the doctor, you put the blood pressure cuff on, you've got a MEMS sensor in there. And Freescale was an early pioneer in developing MEMS sensors for the medical market. Really, it's been the last decade where we've seen pervasive growth of sensors in the consumer segment. And of course, the consumer segment is what's driving the high volume. So up to 400 million units that we had shipped by the early 2000s. MEMS sensors then found their way into engine management systems in motorcycles and in cars. And now I mentioned that the high volume is in cell phones. So it took Freescale 31 years to ship 1 billion devices. I can't make a projection for you on how long it's going to take to ship the next billion, because Freescale has at this time filed an S1 for an initial public offering this year. So I'm limited on my projection ability to tell you what I think is going to be the next billion, but I've given you some insight that we see a 5-fold increase in the use of sensors over the next 2 years. So we expect dramatic growth in sensors. Now, sensors are going to be used in a variety of ways, and I have a short video that I'd like to show you which gives you some insight into the way that we see sensors being used. So we tried to show you there some of the different aspects of sensing technology. And when I think of sensors, I think the word sense is related to the human body. And what I really want in a mobile device is a device that can understand my environment the same way that I understand my environment. I want a device that can be able to understand where I am, which direction I'm going, what time it is, what I need to do, what temperature is, whether I'm indoors or outdoors, whether I'm interacting with other people or whether I'm alone. I want a device that can do all the things that my body can do without me having to tell it all these things. And that's what sensors are for. So in order to do that, in order to most closely mimic the human body interaction with our environment, it requires multiple sensors. And many of these sensors are MEMS derived. So we've already know the use of an accelerometer for functions like knowing which direction I'm moving, or for simple functions such as tilting my device into a portrait or landscape mode, very common today. We know that magnetometers are used for determining the field, magnetic field of the Earth's force, but is not sufficient alone to create a compass. So magnetometers need companion sensors to create an electronic compass. We have a pressure sensor which has multiple types of uses. It can determine certainly an inertial pressure, a sense, a shock, but can also determine the difference in pressure caused by the Earth's barometric pressure. So it can determine weather. It can also determine my altitude based on the environmental pressure. So altimeters being used indoors to determine my location based on, am I on the 3rd floor, am I on the 5th floor, am I on the 6th floor. We have temperature sensors, and we have touch sensors. So the trend that I'm seeing today is multiple sensors being used per device, and all of these sensors having to cooperate together. And I'm going to show you some different ways that we've envisioned for this to happen. There are multiple markets that this is serving. So certainly the mobile phone market is driving the volume, but you see things like orientation detection, tilting of the device to be able to scroll forward and scroll back, gesture detection, even becoming a pedometer. In gaming, you saw in the video several aspects of we want our gaming devices to be extensions of our hands. When we move our hands or move our bodies, we want our gaming devices to move with us. The medical applications, which I'm going to get into a little later with a scenario for you about the wide variety of ways that sensors can have a direct impact on our health and well-being and ability to age gracefully. And then a variety of industrial applications. So we see the MEMS sensor market being used across all of these markets effectively. Let me go into you a little bit of the scenario for how MEMS sensors and sensors in general have evolved. So I've got a chart here that shows a pyramid, and at the bottom you've got basic sensor functions, whether you've got pressure sensor, magnetometer, inertial sensor, touch sensor. I even include radar as a proximity sensor, temperature and voltage sensors. The way the industry started out with these is semiconductor providers or MEMS providers like Freescale and others providing simple devices to our OEM customers, and the OEM customers finding use models for them. The OEM customers adding their own software algorithms to make these sensors functional. And that was really the way that it worked for the first 15 or 20 years of the MEMS industry. But then something happened where more and more customers wanted to be able to use MEMS, but lacked sufficient software ability to be able to do the algorithms they wanted. So they came to us, and they came to other sensor providers, and they said, we'd like to buy some software algorithms with your sensors. So I want to create a pedometer function, and I need the software algorithm that goes with your accelerometer. So that today is the standard. So when Freescale sells a sensor, we have a variety of software algorithms that come along with that sensor that provide a bunch of useful functions. That's what we call sensors with algorithm and logic. So that was the next phase up in the hierarchy. But then we saw that people wanted to create multiple functions that required more than one sensor. So there's some functions I'll show you in a second which require 2 or more sensors in order to cooperate. So when you add 2 sensors together, we call that sensor integration or sensor fusion. And I'll show you an example of how more and more sensors are being used together. And in fact, products are even being developed which have integrated multiple sensors together. Then when you go to the next step is you have multiple sensors together, and now you need to add software to go with those. So maybe you want to run this software algorithm in a small microcontroller. And we call that a sensing platform. And I'll just give you an example of some sensing platforms that are available today. But the pinnacle solution is really when you can take all of the sensors together and incorporate them with both a microcontroller to integrate them and with an application processor to run a rich graphical user interface. Because we want to be able to do is communicate with our devices on an intuitive level, and that requires some sophisticated graphical user interface, which requires a sophisticated microprocessor, and we call that a sensing system. So I'm going to show you some examples of the way these are being used today. Let me show you first some examples of functions that require more than one sensor. So a compass is a great example. Of course, we need a magnetometer to determine the magnetic field of the Earth, but a magnetometer, although necessary, is insufficient to create a compass. So you have to also include an accelerometer or a gyroscope to be able to determine the tilt of the device that you're holding. Are you holding the device straight up? Are you holding it out? Are you tilting it down? Is it moving? And so a compass function requires both a magnetometer and an accelerometer. Gesturing. So if I want to navigate through my tablet or my cell phone by paging right or paging left, requires some fine control through a gyroscope. We also require some gross control through things like an accelerometer. So if I'm walking while I'm gesturing, I want to be able to cancel out the walking and only record the gesturing. So gesturing is another good example of a device that requires multiple sensors. A pedometer is a simple example of a device that requires a simple function sensor, but also a fairly intricate software algorithm to run. So a pedometer is going to require an accelerometer and a microcontroller function. So Freescale has developed a solution which I think will become common in the industry, which is an integrated sensing platform. We call it a smart sensor or an intelligent sensor. And you can see down here we've got a device which in a single package has a 3-axis accelerometer and also has a 32-bit microcontroller. So this has two functions. One, I can create all the software algorithms that I need to create a specific function. So if I want to make a pedometer, I have a device with an accelerometer and a microcontroller together in one package, and this allows me to create a pedometer from one device. It also allows me to create a hub. So if I have to add a gyroscope or a pressure sensor or a touch sensor or a magnetometer, I can funnel those through this smart sensing hub and use the microcontroller inside there to perform algorithms. So it has two functions, both as an integrated device which performs software functionality and then as a sensor hub. And this sensor hub concept actually has some great application in mobile devices. So let me show you an example of a particular application that might be used for the sensor hub. I'm showing here an example of a integrated system-on-chip microprocessor. We use the Freescale, we use the term i.MX, is the brand of our SoC microprocessor. And then I'm showing here a sensing platform, this smart sensor hub that we have, which is a microcontroller and an accelerometer, being hooked to multiple sensors. So in a smartphone environment, you could see this type of engagement, where you have an SoC that runs the operating system, and you have multiple sensors together working together. Of course, in a mobile device, battery life is extremely important. And traditionally, to get the most battery life, we want to put devices to sleep as much as possible. So ideally, we'd like to put that big processor to sleep as much as possible and only have it wake up when we're using it. But if I'm navigating, as an example, or if I'm doing a function that requires sensing, maybe I have my device asleep and I want to be able to wake it up by tapping 2 times. Could be an application. That would require me to have the application processor be aware of the sensor activity at all times and would prevent it from going to sleep. So one option would be to, instead of using the big application processor to monitor the sensors, that device to sleep and use the smart sensing hub to monitor the other sensors. And in this case, you'd have a 10x power savings, where the smart sensing hub can be in low power mode at 100 microamps, whereas the lowest power mode you're going to see on a high performance ARM system on chip is going to be in the 10 to 12 milliamp range. This is an example of an application where you can use a smart sensing hub and dramatically extend battery life while still keeping all of the sensing functions alive on your mobile device. Just another example. If you're doing GPS navigation, GPS navigation is a computationally intensive task and uses a lot of system-on-chip performance. It has to oftentimes use a 3G modem to access the map data. It certainly has to access the 3G navigation data through satellite and do the calculations. And typically today, a GPS, if you're going to be moving in an environment, you want that to be updated at least once a second so you have relevant data about where you are and where you're going. And that requires a lot of power. Another potential use of a smart sensing hub like this is to use what's called dead reckoning. And dead reckoning uses your location, your angular velocity, your linear velocity, and your direction together. So if you have an accelerometer or gyroscope and a magnetometer, you can use dead reckoning to determine your direction and your rate of travel. In this case, you might be able to use the GPS system in a once every 10 seconds mode, and in the other 9 out of 10 seconds, use dead reckoning to track your progress. Again, an example of the ability to dramatically reduce power consumption and increase battery life in a system that uses multiple sensors. We talked a little bit about multiple sensors, but one of the issues that we've got is that even though we have multiple sensors, we don't have the ability yet to mimic what the human body can do. And so I want to talk about some scenarios where by using multiple sensors in the future, we'll be able to better control and interact with our environment. I mentioned the medical industry earlier, and let me go through a scenario with you that is common globally. One global problem that we have an aging population. Thanks to modern medicine and science, we're living longer. Most societies are aging more years. We have a higher percentage of elderly people, and we have more medical devices to care for us. This is good for longevity, but also costs a lot of money. So one of the big issues that economies are facing globally is medical costs are rising, and in many nations, medical costs are the single biggest cost that we endure. Let me walk you through a scenario where sensors might be able to use to increase our ability to age gracefully and also reduce medical costs. So today, if you've ever cared for an elder loved one, you know that many times if a person is suffering from some malady in their old age, they must go to the doctor multiple times in a given week, perhaps 2 or 3 times in a week, maybe 2 or 3 times in a month, because they have to be monitored. Every time they go to the doctor, they have to get a checkup for their blood analysis, for their heart analysis. We need more care as we get older. The biggest cost involved in medical care today is not actually the service rendered, but it's the professional time required by the doctors and the hospitals. And if you've been helping care for an elder, you know the time that it takes either for the elder person to find transportation to the hospital or doctor, or for you to take them yourself. This can be a big burden on people who are caregiving, or a big burden on the people who are receiving the care. So let me show you a sensor network which might be able to use to be able to reduce the amount of time we need to go to the doctor. So on the far left-hand side of the screen, I've got a sensor network of medical sensors. These could be things like blood pressure monitors, blood glucose monitors, EKG or heart rate monitors, pulse oximeters, temperature, your weight. All of the typical functions that you would monitor to determine your relative health. Are you getting healthier, are you declining, or are you increasing? These kind of devices are relatively inexpensive to create and to produce and can be put in the home. If you can put these devices in the home and have a person either through their own devices or through help of a neighbor or loved one monitor their health on a daily basis, this information can be gathered together in what we call a medical gateway. The medical gateway can have the smarts to determine an analysis of the multiple medical functions it's reading and determine a health or wellness diagnosis, or perhaps communicate back to the doctor. So the doctor could prescribe information. We also have sensors on pill devices. So the sensor can tell whether or not the person who needs the medicine has taken their medicine that day. So the ability to put multiple sensors inside of a home with medical functionality, aggregate those sensor readings into a medical hub that can either communicate to the doctor or communicate to the caregiver or communicate to some life support system, is we think a major step forward in creating aging gracefully, reducing healthcare costs, and reducing the need for people to travel back and forth to doctor and hospital together. So this is an example of one way we see the future going, where there's multiple sensors acting together in an area where we don't typically use them today, but an area which might benefit us all dramatically. So in this kind of scenario, this is where we call the sensing system. This is multiple sensors aggregated together in a user interface that's easy for the patient to understand or easy for the doctor to understand. And this is the direction that we see things going together. So two trends I mentioned today. One is multiple sensors being used together. The other is this smart sensing context awareness. So really what we want is all of our sensors being used together in an environment that is easy for us to understand, gives me all of the data about where I am, and gives me an easy user interface to create that awareness. So this requires not only a good sensor network, but also requires an application processor. So today, the application processors that are being paired with these sensor networks include high-performance ARM SoCs. So Freescale has an example. This is an example of some Freescale SoCs that we make that we pair with our application processors. This is our newest line of Cortex A9 processors, which we offer single-core, dual-core, or quad-core processors. And these processors can be paired together with multiple sensors to provide this total sensing solution. And we think that it's important that these things be added together at the integration level. So in order to get these devices to production more quickly, we think it's imperative that the company creating the sensors also has some intuitive understanding of the user interface and the application processor. So what Freescale does is combines our full line of sensor portfolios with our full line of application processors to create reference designs. So this is an example here of a tablet reference design you'll see that uses Freescale system on chip, Freescale audio chip, Freescale power management chip, microcontrollers, but also our full line of sensors. By incorporating these devices together into a reference platform, we allow our customers to get to market more quickly and more easily, and allow them to bring products to market that will benefit everybody more quickly. So we think it's a necessary step. The next step is adding the application processor to the multiple sensor networks. So those are the trends I have for you is more sensors by a factor of 5-fold over the next 2 years, and more intelligence being added to those sensors.